Hello, I'm Gono Kim and I will introduce the paper Video Instance Segmentation. Segmentation in images and video is one of the fundamental problems in computer vision. In this paper, we extended the instance segmentation problem in the image domain to the video domain. Video instance segmentation is more challenging since it not only requires instance segmentation on individual frames, but also the tracking of instances across frames. In this work, a new task video instance segmentation is presented. The new problem aims at simultaneous detection, segmentation, and tracking of object instances in video. This work proposed a novel algorithm called mask-track-RCNN for video instance segmentation. Based upon mask-RCNN, which was a state-of-art model for image instance segmentation, a new branch is added to the framework for tracking instances across video frames. The proposed network mask-track-RCNN adopts the two-stage procedure with an identical first stage, which proposes a set of object bounding boxes at each frame. In the second stage, in parallel to the three branches, classification, bounding box regression, and binary segmentation, we add the fourth branch to assign an instance label to each candidate box. Suppose there are already n instances identified by our algorithm from previous frame. Then a new candidate box can only be assigned to one of the n identities if it is one of the previous instances, or a new identity if it is a new instance. And tracking branch has two fully connected layers, which projects the feature map extracted by ROI align into new features. Since the feature of previously identified instances have already been computed, we use an external memory to store them for efficiency. Model dynamically update our external memory when a new candidate box is assigned with an instance label. In summary, a tracking head is embedded in the mask-RCNN framework to facilitate identity tracking of object instances through interaction with a memory queue. The memory queue is used to maintain all the existing object instances in video. This is training pipeline. Then how can it test? Tracking branch computes the probability of assigning an instance label to a candidate box based on the appearance similarity. However, there are also other information such as semantic consistency and more. Then others propose a simple yet effective way to combine all these queues together to improve the tracking accuracy in a post-processing way. The score for assigning the label n to candidate box I is computed as this VIN. Note that this equation is only used in the testing stage and does not contribute to the training of network. This is all of the method. Let's move on to the experiment result. Existing video segmentation dataset either do not have exhaustive labeling or do not have the object identities. Therefore, this paper presented the first logic-scale dataset named U2Bs for instance segmentation. Notably, mask-track-RCNN achieves the best result under all evaluation metrics and on both the validation and test set. The main difference between proposed method and the other tracked by detective baseline is the new tracking branch, which is trained end-to-end with the other branches so that useful information can be shared among multiple tasks. This video shows 6 samples video with model predictions. The first 4 rows, A, B, and C and D are successful prediction, and the last 2 rows, E and F, are failure cases. In conclusion, this work presents a new task named Video Instance Segmentation and an accompanying dataset named U2Bs. In addition, this work proposed a new method combining single-frame instance segmentation and object tracking, which aims to provide some early exploration toward this task. This is end of the presentation. Thank you for listening.